Hello grade 12s, welcome to my channel, and today we're going to explore some work on analytical geometry. The main question by the student who requested me to have a look at this was mainly asking about 4.5, which is a question on transformations. Okay, now it is no justice to just zoom into that question. But what is important here is to answer all these questions sequentially leading up to this question here. The good thing about transformations in analytical geometry is the fact that here you are merely going to be dealing with identifiable points. So to transform a point is much easier than when you have to perform these transformations within an equation of a given function when we are doing the functions in paper 1. So this is much nicer. But let's have a look at the entire question so that we can work with it all the way. So we're going to be dealing with question 4. All right. So let's read. We are given a diagram of a circle having center M touching the x-axis. Now that statement that says touches is already giving us the fact that the x-axis are actually tangential to this particular circle at point A minus 1 and 0, and as well as the y-axis. That also means this becomes a tangent, okay, at that point B, which is 0 and 1. Okay, so that's very good information. And then we are told a smaller circle centered at N with coordinates minus half and 3/2 passes through M, okay, meaning the center of this other circle is literally at the circumference of the smaller circle, and cuts the larger circle at B and C. And we can see that. Now B and C is a diameter. So once we hear that, we know that literally a diameter of a circle is cut in half by the center. So meaning this radius CN is going to be equal to the radius NB. And that helps us to say we know the coordinates of B, we know the coordinates of the midpoint, we can work out the coordinates of the end of that line segment. Now a tangent drawn to the smaller circle at C cuts the x-axis at D. Okay, so point C is the point where x and y at the moment are not known. Okay, but if this is a tangent, we know the relationship between the tangent and the diameter is that they are perpendicular to each other at the point of tangency. What else do we know? We also know that if this M is the center, we know that the tangent is always perpendicular to radius at the point of tangency. So this is suggesting that we essentially have a situation like that. All right, again, we said this line, the y-axis, are also tangential to this circle at point B. And we know that, again, a tangent and the circle meet at right angles at the point of tangency. This also suggests a similar situation. Now, if this line MA or AM is perpendicular to the x-axis, this line becomes parallel to the y-axis, okay? Because both of these lines are perpendicular to the x-axis. And now what does that mean? It means the x-coordinate at A is literally the x-coordinate at point M. So that means we've got minus 1 for the x-coordinate at point M. Because for a perpendicular line, the x-coordinate is the same for different y values along that line. Now, we also look at the fact that MB is also perpendicular to the y-axis. Therefore, this becomes a line parallel to the x-axis. Now this makes line MB a horizontal line. So on a horizontal line, we've got the same y value for all those different x values. So that means the y value at M should also be 1, which is the y value at B. So this is giving us the center of this circle indirectly. Okay, great. We can see what to do. We can work out the coordinates of C, and from the property that line CD is perpendicular to line CB, we can use that to find the gradient of CD and essentially use our point C, once we know it, to find the equation of this line. From the equation, we can work out the x coordinate at D, which at this point we don't know, but we know for certain that the y coordinate is going to be 0. Now, understanding the diagram and trying to understand even the smaller details of the statements given helps you to know what to do. At this point, it is much easier to go through the questions. So let's start. 4.1 asks for us to determine the equation of the circle centered at M in the form. This is the standard circular form, and we're getting 3 marks. Okay, how do we start the argument? We can literally say we are aware that AM must be perpendicular to the x-axis. Why is that? We know that a tangent is always perpendicular to radius. Okay, that helps us. So what is the significance of this statement? It is to suggest that the x-coordinate at M is going to be equal to -1. Or we can say, in a more systematic manner, it is the same as the x-coordinate at A. Therefore, x at M is essentially -1. Likewise, because this is a similar story, we will be able to tell that essentially MB is perpendicular to the y-axis. That statement that it says touches, it makes it a tangent. Again, we know a tangent is always perpendicular to radius. Great. Then this implies that not x this time, y at M should be equal to y at B. Therefore, y at M is going to be 1. And that concludes that point M is -1 is to 1. So this is important. Of course, I'm just going about it systematically. You could easily quickly rush through this. But for me, it's very important to work on this one. We can say also, we can tell that the radius of the circle is going to be equal to 1 unit. This is by inspection. As you can see, from 0 to point M, it's 1 unit. So it should be 1 unit. So what do we then say? We can say then circle center M will be such that x minus the x coordinate at the center is going to be +1 all squared y minus 1 all squared, which is minus the y value at the center, should give us 1 squared. So we are substituting all these little things. So, which gives us an equation of x plus 1 all squared plus y minus 1 all squared is equal to 1. Of course, you could just jump into this as the final answer. It's not a big deal. As you can see, yes, it's 3 marks, but there's a few things you needed to know. But the mark is getting the point M, because that's the significance of all of this, and substituting into a correct format and essentially getting the answer. Perhaps this substitution is very weak because we are substituting what we already know. So most likely I wouldn't give a mark there. but perhaps in also noticing that the radius is 1 is perhaps more, it's carrying more of the weight than just the substitution here. Okay, great. So this is how you go about it. Of course, the examiners can decide otherwise where the marks should be. This is why in the instructions you are advised to show all your workings, so that if they decide the marks are essentially in other areas than the generic areas or the standard areas, then you don't lose those marks. Okay, but let's go on. There's not so much trouble for you there. We are to find the coordinates of C. Again, the question says calculate, so you cannot just show us the answer only. We need to see your calculation. So we can say, look, C is fine. Is a point such that the x-coordinate at C plus the x-coordinate at B all over 2 should give us the x-coordinate at N, the midpoint of CB. Likewise, y at C plus y at B over 2 should give us the y-coordinate at N, the midpoint of that line segment CB. This implies that our point C is going to be x at C is what we want, plus x at B is 0, over 2 should give us minus a half. And then we want the y at C plus y at B, which is 1, over 2 should give us 3 halves. Okay. Then we can make a conclusion that C would be the point such that the x-coordinate at C, just cross-multiply that 2, okay? And then it cancels this 2 in the denominator. We remain with minus 1. 0 is nothing, so basically this coordinate is minus 1. Next one, we transpose the 2, we cross-multiply the 2, it cancels this 2, we then transpose the 1, so 3 minus 1 gives us a 2. So essentially these are the coordinates of C. So it's a much fairer calculation. We are getting 2 marks. So most likely for that show of how we calculated it, and the final answer should give us those easy 2 marks. Okay. 4.3 says show. Now a show is more like a calculation. You need to display everything. Show that the equation of the tangent CD is given by y minus x equals 3. Okay, that's a bit of work. But we also know something, that look, the gradient of CD multiplied by the gradient of CB is going to give us minus 1. How do we know that? We know that essentially the tangent is always perpendicular to the diameter. Okay. So that's easy. Now this implies that the gradient of CD times, now we need to calculate this gradient, so I'm going to do it here. I can take y at C, which we found to be 2, and subtract y at B, which is 1. Divided by x at C, it's minus 1 minus 0. Should be equal to minus 1. And then I know I can make a conclusion that the gradient of CD should be, now I'm going to get a minus 1 here. So when I divide by minus 1 on both sides, I get a positive gradient of 1. Does it make sense? It does, because this is a positive slope. So whatever the value may be, all I know is that if it is positive, I'm most likely correct. Then I know that CD, line CD, is going to be such that y minus y1 equals m into x minus x1. I'm going to use point C, which is the point through which this line passes. Then I substitute y minus 2 is equal to the gradient 1, x into x Now minus minus 1 is going to be plus 1. Okay. Which implies that y minus 2 is going to be equal to x plus 1. Then I want to put it in the format that they gave us, so we can conclude that y with transpose x is going to be minus x equals 1. When you transpose the 2 there, it becomes a 3. Nice and easy. So essentially, finding the gradient is important. Substituting this point into a correct format and the answer in the manner that it was given. Yes, it may be already given. You may say, well, no mark for it, but it has to have a mark. But this calculation of the gradient itself of that line CB is a whole calculation on its own, so it gets a mark. So this is how these 4 marks could be scored. Obviously, what I'm showing you is just my own guideline, which is not truly my own guideline, but I would say it's a standard guideline on how marks are allocated per question. But examiners can decide where they put these marks to punish a student who doesn't follow the general instructions of displaying all their workings when the question demands so. When it says show, you do not have a choice. When it says calculate, you do not have a choice. But a question that says determine is a bit of an open-ended. You can do it by inspection, you can do it by calculation, or any means necessary. All right. Now, question 4.4 says, determine the values of t for which the line y equals x plus t will not touch or cut the smaller circle. Now, if you look at this equation right here, the line for CD, it could be written in standard format as y equals x plus 3. Now, there's a striking resemblance between these two. We can see that the y-intercept is a 3 there, with a gradient of 1. Here, the y-intercept is a t, with the same gradient of 1, meaning this is the line parallel to this tangent. So a line parallel to this tangent, say for example, we draw any line. Let's give it a different color. So if we draw a line that is parallel to this particular line, obviously we're going to assume this is a line parallel to CD. Now, when we essentially take CD to the x-axis, to the y-axis, we will note that the y-intercept is 3. So there we've got 3. Now we've got this other line, which is parallel to CD, but it has a y-intercept that is greater than 3. Obviously, can you see when that t is a value greater than 3, this line doesn't touch or intersect the circle, the smaller circle. If we do the same and say, where would the other tangent be? Perhaps it could be a line that cuts through here, but it's parallel to the others. But we can see that when the y-intercept of this particular line, meaning the value of t, is less than 3, perhaps greater than 1, which is the identifiable point, this line essentially cuts through the circle. It becomes a secant. When the y value or the y-intercept is literally 3, it becomes a tangent. It touches the circle. And we don't want a touch, we don't want a cut. So the other one, across this line, the diameter, we would get another tangent passing through essentially point B. So we are suggesting this line is also parallel to these others. Essentially, when the y-intercept of this line is exactly 1, it means this line will be a tangent to the smaller circle in this manner. And that's not what we want. But if we draw another line parallel to that, but passing through a value less than 1, here on the y-intercept. So we can see if the y-intercept is less than 1, this line will not touch or cut the smaller circle. So this means this is a line that we can approve for our answer, and that is a line we can approve for our answer. So notice the y-intercept is a value greater than 3, and the y-intercept could be a value less than 1, and that satisfies the constraint of not touch or cut the smaller circle. So this is a higher grade question because it seeks an understanding of this kind of relationship in a student's mind. So it may have just 3 marks, but it's really hectic. But we can see here that t can be less than 1, or t could be greater than 3. So for me, that gives us 2 marks. I don't know why they're giving 3 marks, so unless there's something I'm missing, but either way, whatever, we will see what to do about it. So we'll just leave it at 2 marks, probably a misprint there. All right, let's go for 4.5, which is the main question by the student that wanted me to have a look at these transformations. All right, so let's quickly look at it. We are told here that, okay, maybe let's remove what we were using as a means to an end because it's making our diagram a bit busy. That's the last thing we want, okay? Now, we are told a smaller circle centered at N is transformed. Now, this word transformation can mean 2 things. It can mean a reflection or a translation. All right. As we know, a reflection is a flip or it's a somersault. Translation is a push, it's a shove, it's a shift. Okay, so this is something we need to consider. So if we are transforming this circle, it means we are either flipping it or translating it or pushing and shoving it, such that point C, can you see point C is translated. Now they are giving us that the one that is at play here, a transformation here, is literally a translation. So they are essentially freeing us from fishing for what could this transformation be. It is literally a translation, because if we are translating a point on the circle, it means we are essentially performing a translation of the entire circle, because every other point will translate the same way as any point that we have identified. So let's have a look at this one. It says such that point C is translated along the tangent. So meaning point C is being just pushed along that tangent line to point D. Now we don't know the coordinates of point D entirely. So we are told here to calculate the coordinates of E. Can you see point E, the new center of the smaller circle? Okay, great. So that means if C is moved to point D, it becomes point, say, C prime or whatever. Now we want N, the center of this circle, to be translated in the same manner. So what would those coordinates be? So we can see clearly we need the coordinates of D fully before we can understand what translation is that. So we can say, look, point D is such that 0 is equal to x plus 3. Why do I know this? It's because this is the x-intercept of CD. So this is line CD. So if I use y as 0, it means I'm working the x-intercept. So maybe let's not rush for the conclusions. That implies that our x will then be minus 3. Therefore, we can say point D is the point minus 3 and 0. So that is important for that to come out. So that becomes a minus 3. Okay, maybe let's just put it nicely. -3 and 0. Okay, so what can we learn? Now look, what were the coordinates of C? We found them to be -1 and 2. So can you see, that means on the y we lost 2 to 0. So that means we translated that point downward vertically by 2 units. So 2 minus 2 gives us a 0. But how did we get to -3? It means we also translated it to the left by 2 units, because -1 minus 2 gives us -3. So we can say, since C is moved to D, it is such that the smaller circle N is translated down by 2 units and to the left by 2 units also. This is very important to notice. So since we are transforming C to D, we can clearly see that then the smaller circle is being translated downward by 2 units and to the left by 2 units. Now, what do we then follow? We can say then this new point E is going to be that center N, which is -0.5. Then we are taking it to the left by 2 units, because when we translate to the left, we're basically moving the x values. Is to, now this was 3/2, and then we are translating that down 2 units. So therefore point E becomes, you multiply that, it becomes -4. -4 minus 1 is going to be -5/2. Is to, you multiply that, it's a 4. 3 minus 4, it's -0.5. Okay. So that is how a question like that can be attacked. So here, again, it's not an easy question. It's a higher grade question as well as that, because here you needed to understand something. You needed to explore something before you can come to this final calculation. So what is important is determining the x-intercept D initially from the line of CD. Then showing how we are translating this, because the question said calculate. So these are calculations in a strategic way. And finally, for the full coordinates of that point E. Okay, so that's it, guys. So that was essentially the question. So it's much easier to translate a point that you can identify. If you are translating to the left, you simply subtract from the x coordinate. If you are translating down or up, you simply subtract or add to the y values. So it's much easier than in paper 1 when you are handling functions. All right, let's do 4.6. Now 4.6 says it is given that the area of quadrilateral OBCD. So where is that? So there is quadrilateral OBCD. Okay. So we are told here that the area is 2 square units. Okay. Is 2a squared square units. And a is greater than 0. So that's a very important property. Then we are told to show. Again, a question that says show, you can't just come up with an answer. You must show us your path taken. So it means we need to prove that a is the square root of 7 over 2 units. So how do we handle this? Well, we're going to handle it this way. So if we split our quadrilateral into 2 geometric figures, like we can see here, the yellow trapezium and this green triangle. it is much easier to work with this, because the good thing is that we know all these points in a nice way. So you can decide how you want to handle this kind of a situation, but this is the best way you can split this particular one. But another student may decide to draw a big triangle going all the way to the y-intercept of CD and come down to the origin and back to the x-intercept. So calculate the area of this big triangle, then subtract the area of that smaller piece, okay, the white triangle. But the challenge is that you will have to use the distance formula to find that side and use the distance formula to find CB. So it will give you a bit more work than this would. Another student may decide to split this in this way into two right-angled triangles. Again, it forces you to use the distance formula to work that side and use the distance formula to work that side, whereas this other triangle is much easier to deal with. Either way, how you see it is how you work it out. So my advice is that as you practice, try different techniques and see which techniques tend to be labor intensive and which techniques tend to be a bit simpler, so that you don't waste time when the exam is upon you. You try and figure out the quickest route. So a little bit of thought is important here. You can't just go about it blindly. You will suffer. Anyway, we can see that essentially the area of OBCD is going to be equal to the area of that triangle, say CDA. So I'm just going to go ahead and push. So the basal side is going to be AD. The vertical height becomes AC. Plus the area of a trapezium is half the sum of the parallel sides, which is AC, plus OB, times the perpendicular height between the two. This is OA. Okay, so this is much easier. This implies we were told this area is 2a squared. So this means 2a squared is equal to half. Now AD, you see why it's easy. You know from -1 to -3 is just 2 units. So you don't have to perform some crazy calculations here. Then again, from the basal line, which is 0, up to point C, it's just the y value there, which is 2 units. Can you see how nice this is? It is indeed nice. So AC is coming back again. We saw that it's 2 units plus OB. We can see that OB is just 1 unit up. So it's going to be 1. The perpendicular height is OA from 0 to -1 is just 1 unit. Remember, we're dealing with distances. So we know that our 2a squared is going to be equal to, that becomes essentially just 2. Plus this becomes a 3/2. Now we perform yet another mathematical gymnastic. I take this 2 and multiply there. I get 4 and then I add 3. Then it becomes 7/2. Again, you will work fractions as however way you were taught, but there are many tricks here. Now we have to perform a gymnastic of dividing by 2 on both sides. So let's have a look. We will see that a squared becomes 7/4. Again, you can go about it the long route, but there's no need. And then we perform our last gymnastic, which is to take the square root on both sides, right? So we can see that our a comes out as, now remember we were told a is positive. Ideally we would say plus or minus, but in this case, since we were told a is positive, it's going to be the square root of 7 over the square root of 4, which is literally 2. And that is units. Essentially, that question is done. So this is another question that seeks to destroy students' confidence if they're not careful. It's a higher grade question, literally. So essentially, guys, you are dealing with a lot of higher order stuff, but it's not out of reach if you know your work. So how do we score the marks here? I believe essentially this is a calculation on its own. It's a calculation on its own, and essentially the general substitution is important. And then obviously picking out that answer is an important situation. Okay, so essentially, where does the last mark come from? I don't know. It really depends on how one wants to attack this. I can say 2 marks for the answer, or maybe just to distribute this perhaps would be fair, because I mean these arithmetic gymnastics here, they are not really mark worthy, to be honest. The mark is coming back in the fact that we are choosing the positive answer instead of writing both, okay? Or at least choosing the negative answer here, given the property that a is greater than 0. Alright guys, I hope you enjoyed the video. I will see you next time. Goodbye.